Every day, you trust your life to a simple three-sided shape without even realizing it. The triangle isn't just a geometric curiosity. It's the invisible guardian that keeps bridges from collapsing beneath your car and prevents your home from crumbling during violent storms. The power of the triangle reveals itself in moments of catastrophe and survival. When an 8.8 magnitude earthquake struck Chile in 2010, modern triangular braced buildings remained standing while rectangular structures crumbled. This wasn't luck. It was geometry at work, saving thousands of lives through principles understood since ancient times. Let's explore why the triangle stands as nature's perfect design solution. Unlike squares or rectangles that can be easily deformed, a triangle is inherently rigid. Once the lengths of its three sides are fixed, the shape cannot change without breaking one of those sides. This fundamental property makes triangles remarkably resistant to external forces trying to distort them. Think about what happens when you push on a cardboard box. It easily collapses as its right angles deform. But add a diagonal brace, creating two triangles, and suddenly that same box becomes surprisingly strong. This simple modification transforms weakness into stability. This principle appears throughout history, from the ancient pyramids of Egypt to the steel skeleton of the Eiffel Tower. These structures have survived for generations, precisely because their designers, either through intuition or calculation, harnessed the triangle's exceptional properties. Consider this striking fact. Modern bridge failures have decreased by over 80% since triangular truss designs became standard. Before this innovation, thousands died in bridge collapses that could have been prevented. The introduction of triangular support systems quite literally saved lives through mathematical elegance. How exactly does the triangle distribute force so effectively? When pressure is applied to one corner, the force travels along both connecting sides, dispersing energy rather than concentrating it at a single breaking point. This distribution means that triangular structures can withstand enormous weight and pressure relative to the material used. Let's pause to consider, why do you think it took humans so long to fully understand and implement triangular principles in all our major structures? And another question worth reflecting on, what might our cities look like today if we had never discovered the structural advantages of triangles? The triangle's life-saving potential extends beyond bridges and buildings. After the devastating Haiti earthquake of 2010, emergency shelters utilizing triangular frames proved significantly more resilient than traditional designs. These simple structures required fewer resources, yet provided safer temporary homes for thousands of displaced survivors. Consider the humble roof truss, those triangular wooden frameworks supporting the roof above your head. This design prevents snow accumulation from collapsing your ceiling during winter storms. Without this triangular innovation, thousands more homes would fail catastrophically each year during severe weather events. Even in aerospace engineering, where lives literally hang in the balance, triangular principles reign supreme. Aircraft frames utilize triangular trusses to maintain structural integrity while minimizing weight. The alternative would be either prohibitively heavy planes or dangerously fragile ones. This leads us to wonder, what other shapes in nature demonstrate similar extraordinary properties that we might harness for safety and efficiency? And more broadly, how might understanding basic geometric principles continue to save lives in the future? The triangle's influence extends into microscopic realms as well. Nanotechnology researchers have discovered that triangular arrangements of molecules create some of the strongest known materials. This insight is leading to new damage-resistant designs for everything from building materials to vehicle bodies, innovations that will undoubtedly prevent countless future injuries. Perhaps most fascinating is how triangular principles appear spontaneously in nature. From the molecular structure of graphene, one of the strongest materials ever tested, to the way beehives distribute weight through hexagonal patterns composed of triangles, we see this shape emerging wherever strength is essential. Even our bodies utilize triangular principles. The arches of our feet form triangular supports that distribute our weight efficiently while walking. Our pelvic bones create a triangular structure that protects vital organs. These biological implementations of triangular strength have evolved over millions of years. We should consider, how might biomimicry, copying these natural triangular designs, lead to even safer structures in the future? And a more philosophical question: what does it tell us about the universe that such a simple shape holds such profound protective power? The triangle's life-saving legacy continues to expand. Modern earthquake-resistant buildings incorporate triangular bracing systems that can absorb and dissipate seismic energy. These designs have demonstrably reduced casualties in earthquake-prone regions worldwide. Engineers estimate that widespread implementation of these principles could save tens of thousands of lives in future seismic events. Similarly, hurricane-resistant home designs now incorporate triangular supports to withstand powerful wind forces. Communities that have adopted these building codes have seen dramatic reductions in structural failures and associated casualties during severe storms. Even in everyday objects, triangular principles protect us. The crumple zones in modern vehicles incorporate triangular designs that absorb impact energy during collisions. This simple geometric application has saved countless lives on highways around the world. This raises an important question: how can we better educate people about these fundamental principles so they can make safer choices in their own construction projects? And another consideration: what responsibility do engineers and architects have to implement these life-saving principles, even when not required by building codes? As we look to the future, the triangle's role in life-saving innovation shows no signs of diminishing. Engineers developing protective structures for climate change adaptation, from flood barriers to hurricane shelters, continue to rely on triangular principles. As extreme weather events become more common, these designs will become increasingly crucial for human safety. Space habitation presents another frontier where triangular strength will protect human life. Proposed structures for lunar and Martian habitats prominently feature triangular support systems to withstand extreme conditions while minimizing material requirements. The humble triangle, 3 simple lines connected at 3 points, deserves recognition as one of humanity's greatest lifesavers. From ancient intuitive designs to modern engineered precision, this shape has quietly protected generations through its mathematical perfection. The next time you drive across a bridge, sleep beneath a roof, or watch an airplane soar overhead, remember that your safety is being guarded by a shape so fundamental we often take it for granted. The triangle doesn't just define geometry, it defines survival itself. Let's close with a final thought-provoking question: what other fundamental principles might be hiding in plain sight, waiting to revolutionize our understanding of safety and structure? In a world of increasingly complex challenges, sometimes the most powerful solutions are also the simplest. The triangle stands as proof that understanding fundamental principles can save thousands of lives, an elegant reminder that sometimes the most basic shapes hold the most profound power.